Alright guys, so I'm going to make a quick video just summarizing product prediction of the different types of reactions. We're going to start with synthesis. Remember that a synthesis is when we're going to make one product. And if we make only one product, the only thing we have to do with a synthesis is squish, right, our symbols together. Cross any charges that we have, and then balance that equation. So for example, if we had potassium reacting with oxygen, right? So the first thing I need to do is write the symbols of my reactants. So potassium is K and oxygen is diatomic. When that reacts, I'm going to squish K and O together. But just because I have a subscript on my reactant side does not mean I have that same subscript on my product side. So I'm going to squish K and O together. Then I'm going to cross the charges. So I need to write my oxidation numbers from the periodic table and then cross down and make K2O as potassium oxide. I then need to balance that equation. If I have two oxygens and only one oxygen, I need a 2 out front. That makes 4 potassiums for my balanced chemical equation. For our second type, we're going to talk about decomposition. And in a decomposition, right, we only have one reactant. When I only have one reactant, I'm going to make sure that I split those up. I then need to check for diatomics, followed by balancing that equation. So if I have a decomposition, which we'll just make ammonia decompose, so NH3. As ammonia decomposes, it's going to produce N's and H's. So I'm going to split those up. Again, subscripts on my reactant side don't come to my product side. I then ask myself, what's the name of N? Oh, his name is nitrogen, and this is hydrogen. So they're both diatomic, and then I need to balance my equation. 2 nitrogens, so I need 2 nitrogens, and then I need 6 hydrogens to balance. Okay. Our third and easiest type to do product prediction was combustion. So in a combustion reaction, right, I'm always going to have some sort of hydrocarbon, C's and H's, reacting with oxygen. That's going to fuel that fire, right? And so to predict the products, they always produce carbon dioxide and water every single time. So easy to predict. And then sometimes harder to do so is to balance that equation. So let's say I have propane, which is C3H8. It's going to react with oxygen. Oxygen, right, is diatomic. And in predicting those products, when I see this hydrocarbon reacting with oxygen, I'm going to produce carbon dioxide and water. So then that's going to balance 3 carbons. I need 3 carbons, 8 hydrogens. 4 times 2 gives me 8. And then 6 plus 4 more gives me 10 oxygens on this side. And so 5 times 2 is 10. Okay. Our next 2 types are longer and a little more arduous to predict, right? So the next one that we talked about in class was double replacement. And in a double replacement, we have a wife swap scenario, right? So all the cations and anions are going to switch. Sometimes it looks like a double rainbow, or the OI, right? The outers and inners are going to come together. So like the FOIL method in math, but without the first and lasts. And so when I do a double replacement, I'm going to write the charges. I'm going to switch partners, always making sure that the cation comes first. And then I'm going to recross those charges and then balance that equation. So for example, let's say I have magnesium sulfate plus water. I'm picking water here on purpose because we have to be careful when we're talking about ions. We can't draw water as H2O. We need water to be in its ionic form, which is HOH. So magnesium is a +2. Sulfate is a -2. So those are even. That's nice. Water I have to write as HOH, hydrogen hydroxide. So hydrogen's a +1 and hydroxide's a -1. And so that's going to produce, in my double rainbow, the first cation can't go with sulfate. It's already with sulfate. And it can't go with hydrogen because two cations wouldn't bond. So we go all the way and do the outers, right? The outers. And so we're going to produce magnesium hydroxide. And the charges come with them, and I need to recross those charges. And then the hydrogen is my other cation, and it's going to come and get that other anion. So hydrogen sulfate is also called, right, sulfuric acid, right? So hydrogen's a +1, sulfate's a -2, so I got to cross that charge down and have two H's there. That's a 1, sorry. And so here, when I'm done recrossing my charges and I balance, I've got 2 hydroxides, so I need 2 hydroxides. That gives me 2 hydrogens, but I already have 2 hydrogens. So there's my balanced double replacement reaction. And then lastly, we've got the one that is the worst one, which is single replacement. And remember what makes this one so terrible is that you have to remember who replaces who. So in this scenario, we know that everyone's changing places. But in a single replacement, when you have a compound and an element, you got to be sure that the first thing you do is write the charges. See who's alone. Check your activity series to see if the reaction occurs. Remember, if it's higher, that reaction does occur. If it's not higher, then they will not replace. Okay. After you know the reaction occurs and you have your charges, again, you always want a cation and an anion together, right? So then you're going to switch the switch and ditch, right? Someone will be alone when you're done. And then recross, and then balance. Okay? So in a single replacement, if we have, I'll just do hydrochloric acid and copper, right? So if I have hydrochloric acid and copper, the first thing I'm going to do is write my charges. So +1. Oh, well, I need to tell you what copper it is. Sorry. -1. We'll make it copper 2 just to make it more interesting, right? It won't be that interesting because when I check my activity series, copper is alone, right? And he is looking to replace the hydrogen because those are both the cations. So I'm looking for copper and hydrogen. When I look on my activity series, I see copper is alone, and he's right here, and hydrogen is above him. So if I see copper's alone and I ask myself, is he higher than hydrogen? No, he is not. And so this will result in a no reaction. However, if I take that HCl and I react it with, let's say, zinc, I'm going to write my charges, and I'm going to check my activity series. This time I'm looking at zinc, who's alone, and hydrogen. So my hydrogen's here, but zinc is up here. Zinc is higher than hydrogen. So this reaction will occur, and zinc will come to take the chlorine, and hydrogen will get ditched, right? Go cry alone in the bathroom. So then zinc and chloride will come together, and hydrogen will be alone. I then have to recross. Zinc is a +2 and chlorine's a -1, so that's going to be ZnCl2. But then this is H all alone, and hydrogen alone is hydrogen. It will be diatomic. So we have to remember our diatomics as well. So when I balance this equation, I just need to put a 2 in front of that HCl to balance. I hope that helps. If it doesn't, please let me know. And I'll see you soon.